The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. We've got a number of people that are signed up to attend this lead webinar, and so what we'll do is we'll wait just a couple of moments for others to join us. We'll get started here in just a couple of minutes. Thank you for attending, and again, we're waiting just a moment for others to join us. We will start in just about 2 minutes. Again, thank you guys for joining us this morning, and we have about 90 people that have signed up to attend. We'll wait just another minute here before we get started on the Learn, Educate, Accelerate, and Discover, the lead webinar for this month. Well, we can go ahead and get started here. My name is Jeff Apsley, and welcome to the lead webinar. LEAD stands for, or is an acronym for Learn, Educate, Accelerate, and Discover. And again, good afternoon, everyone. I'm really pleased to be able to spend some time with you today. In the next 60 or so minutes, we'll consider the Citrix ADC, what it is, and how business greatly benefits from its many features. We'll take a look at the Citrix ADM, the Application Delivery Management, how it assists in planning, monitoring, and protecting your vital environment, all from a single management tool located in the Citrix Cloud. Again, thanks everyone for joining us today. Today our goal is to look at, and in the light of a typical business need, the real value we have will be considering the Citrix ADC and ADM technologies, and how these technologies provide value with business critical features. We'll be discussing these in the context of the following topics: business continuity, is it important? Citrix ADC, what does it provide for mission critical applications? High availability pairs as one method of protection. Global server load balancing as another form of protection. And then finally, Citrix ADM for analytics to answer the question of am I, or better yet, is my organization protected? As part of the topics presented in this webinar, we are presenting this webinar in an executive briefing format because of the time constraints of this webinar. These and many more topics, related topics, are covered in depth with reinforcement via hands-on labs, instructor-led lecture, and colleague interaction in the many official Citrix courses. Official Citrix classes can be self-taught or self-paced e-learning or instructor-led, in person or online, and in reality, The Citrix classes are the best preparation and enablement of Citrix technologies for the IT professional available today. The topics presented in this webinar deal with the Citrix portfolio of products. I'd like to point out that Citrix Workspace provides real value to any business and their end users with enterprise-level offerings such as Workspace App, Citrix Content Collaboration, Citrix Endpoint Management, Citrix Secure Browser, Citrix Hypervisor, Citrix App Layering, and CVAD, or Citrix Virtual Apps and Desktops. On the networking side, the focus of today's webinar is the following Citrix technologies: the Citrix Application Delivery Controller, or Citrix ADC, the Citrix Application Delivery Management, or ADM. Citrix networking also includes, but is not in the scope of this webinar, the SD-WAN, Citrix SD-WAN, the Citrix Web App Firewall, Citrix Gateway, Citrix Secure Web Gateway, and Citrix Intelligent Traffic Management. The question seems to be rather obvious, though. How important is business continuity? Businesses provide either products or services or both. And what they produce, customers want and are willing to pay for. The reason businesses hire employees is to produce these products or services. The company must provide the tools and resources that allow their employees to produce products and services. The company must also provide the tools and resources that allow their customers to access and purchase and consume those products and services. All of this is considered as normal business. The continuity of our business, well, you get the idea. I'd better get going or I'm going to confuse all of us. Business continuity plan, or a disaster recovery plan. BCP, DRP, there are differences in how each are structured. The business continuity plan consists of a business impact analysis, risk assessment, and an overall business continuity strategy, while the DRP includes evaluating all backups and ensuring that a plan to repair, recover, or replace any failed equipment or process. While the plans work together, they can be seen as two separate concepts. So let's consider the BCP. It is a plan to continue business operations even if one or many components in the corporate infrastructure fail. DRP, or disaster recovery plan, is a plan for accessing required technology and infrastructure after a catastrophic disaster. You might think, I have a good business continuity plan in place already, so why do I need a DR or disaster recovery plan also? Business continuity plans refer to strategies and protocols that enable a company to operate during and immediately after a tolerable failure. A company's business continuity plan has evolved to become the crucial blueprint for guiding an institution through the process of preventing a business interruption. This plan outlines what needs to happen to ensure that key products and services continue to be delivered even if components within that infrastructure fail. The key here is tolerable failures. A tolerable failure is a failure of a component that is already protected by, say, redundancy or high availability. You get the idea. If it's mission critical, we protect it with high availability or fault tolerance. So how important is business continuity? The inability of employees to access your infrastructure means that they cannot produce the products and services that your company needs. And if the customers or clients cannot access your products or services, they cannot purchase or transact business. In either case, failures cost money and lots of it. And so we have the client trying to access the products and services. If that access goes away, we're in trouble. So what we want to do is we want to create high availability, or we want to create another path or route for that access. And that's what we get with the ADC. So let's move on. The Citrix ADC can provide HA protection for mission critical applications. Citrix ADC load balancing is a feature that provides protection for mission critical applications. Application layer load balancing. Citrix ADC load balancing distributes user requests for web pages and other protected applications across multiple servers that all host the same content. The load balancer is logically located between the client and the server farm and manages traffic flow to the servers in that farm. The Citrix ADC can use any number of algorithms or methods to determine how to distribute the load among the multiple load balanced application servers that it manages. Persistence on a load balanced virtual server must be configured to handle certain types of web applications, like supporting shopping carts. Persistence overrides the load balancing method and routes all connections from the same endpoint to the same service. Load balancing occurs upon initial connection, and then after that we maintain that connection. Least connections is the default load balancing algorithm and is concerned with protecting available resources from saturation. Application load sharing is distributing traffic between multiple servers to limit the bandwidth and capacity used on each server so that we maintain performance and prevent outages. Application high availability provides fault tolerance and removes the dependency on a single server. Typical use cases: load balancing of websites or Microsoft services like Exchange, Lync, and SharePoint. Load balancing of Citrix Storefront for published desktops and applications. Load balancing of infrastructure dependencies like DNS, FTP, RDP, and SIP. All of these services and servers can be load balanced and protected in case of an outage. Database-specific load balancing can be done. Now, with the database load balancing, we would want to adjust our monitors. We assign monitors to our load balancing. The monitors periodically check the health of the back-end servers and feed that information to the load balancing virtual server so that it can make an intelligent decision as to what and where to route the traffic. So for database, we would have a specific monitor. Ping would be a terrible monitor for a database. Ping would just determine whether that machine is running or not, or the stack was available, the network stack. A far better monitor would be a query. And so what we would do is we would produce a query that says on table 3, column 1, field 7, what is the result, and then we pre-program that in and we periodically check to see if the database is online. And so we can modify those monitors to make the load balancing very effective and very accurate. Link load balancing, unlike layer 7 load balancing, link load balancing is a service representing a router or next hop. Methods that are applicable to link load balancing are round robin, destination IP hash, least bandwidth, and least packets. Ping is the default monitor, but configuring a transparent monitor is recommended. Monitoring is critical for link load balancing functionality and accuracy. The Citrix ADC appliance is located and placed between two sets of firewalls. The external set of firewall typically handles the egress traffic, and the internal set typically handles the ingress traffic. Firewall load balancing is supported only for Mac mode load balancing, virtual servers. Load balancing the firewalls provides protection against firewall failure and firewall saturation. We can even route a denial of service attack to a single firewall and all other normal traffic to the remaining firewall instances. So firewall load balancing or a multiple firewall environment is supported and maintained by the Citrix ADC. Load balancing of Microsoft Exchange is designed to minimize external access to an Exchange deployment to prevent possible malicious attacks. The Citrix ADC handles all internet-facing mail traffic and also adds an additional layer of message protection and security against viruses and spam. The primary design goal of Exchange load balancing is for simplicity of scale, hardware utilization, and failure isolation. Load balancing can provide protection against or for Active Directory, abuse of Active Directory, DNS, DHCP, AAA, authentication, authorization, and auditing. For example, a medical institution had a mission-critical application that constantly accessed Active Directory for current user object permissions. Even though they had deployed multiple Active Directory servers, the application was configured with the IP address of only one of those 80 servers. That produced a single point of failure, even if there were multiple Active Directory servers available. The solution, without reconfiguring the settings in the application, reassign the IP address from the Active Directory server to a VIP on the Citrix ADC, and then give the AD server a new IP address. Now all permission queries are load balanced across all AD servers. An additional benefit is that the administrator can add and remove AD servers at any time without interrupting productivity. The third topic that we need to consider today is the Citrix ADC high availability. Up till now, we've concentrated on using the Citrix ADC to protect applications and resources in the back end. But what about protecting the ADC itself? To set up a high availability configuration, you create two nodes, each of which defines the other's Citrix ADC IP address, or the NCIP address, as a remote node. By logging on to one of the two Citrix ADC appliances, then you configure for high availability and add a node. You specify the other appliance's IP address and the new node, then log on to the other appliance, add a node, and add the first appliance IP address. An algorithm determines which node becomes primary and which becomes secondary. Now that's the manual approach. If you use the configuration utility, it avoids having to log on to the second appliance. In fact, the wizard asks what is the IP address of the secondary node and the password. And if it's the same, you can continue on. If it's not, then just add that second password there. And in just a few clicks, the two ADCs are joined into an HA pair. Remember, this HA pair is in an active-passive configuration. That means that all traffic goes through the active node and no traffic goes through the passive node until there is a failure. On the Citrix ADC, there are three things that will cause a failover event to occur. An interface failure on an interface that has HA monitoring enabled, an SSL card failure, or the primary is no longer responding to a heartbeat packet. Now those heartbeat packets are transmitted on UDP port 3003. When there is an interface failure or an SSL card failure, the primary system contacts the secondary system and notifies it of the failure. The primary system then demotes itself to secondary, and the secondary promotes itself to the primary role and then performs a gratuitous ARP update on all Citrix ADC IP addresses. When there is a heartbeat failure, the second reaches the lost heartbeat threshold and promotes itself to the primary status. If you issue the stay primary command on the primary device, then it gets preferred node status and will fail back when it recovers from a failure. HA configuration is made up of 2 or more ADCs working in an HA configuration. Citrix ADC HA is active-passive, as we said a moment ago. HA doesn't cover up upstream router failure or back-end server downtime or failure. Paired Citrix ADCs share a configuration. In fact, that configuration is replicated between the two devices. The only thing that's unique between the two devices is the IP address of the unsip address of the device. The ns.config will have different node ID listing for the paired system. A high availability deployment of 2 Citrix ADC appliances can provide uninterrupted operation in any transaction. With one appliance configured as the primary node and the other as secondary node, the secondary node monitors the primary node by sending periodic messages called heartbeat messages or health checks to determine whether the primary node is accepting connections. If a health check fails, the secondary node retries the connection for a specified period of time, after which it determines that the primary node is not functioning normally. The secondary node then takes over for the primary node, and that process is called a failover. High availability ensures that if one node experiences a failure, the other node can take over because it has identical configurations and it is on standby. On the Citrix ADC, we refer to the active system again as the primary and the passive system as the secondary. In an HA configuration, the primary and secondary appliances should be of the same model. Different Citrix ADC models are not supported in an HA pair. For example, you cannot configure a model 10010 and a model 7000 as an HA pair. In an HA setup, both nodes must be running the same version of the Citrix operating system. The primary and secondary system must each be configured with their own unique IP address. If you create a configuration file on either node by using a method that does not go directly through the GUI or the command line, for example, importing SSL certificates or changing to startup scripts, you must copy the configuration file to both nodes or create an identical file on each node. Gratuitous ARP is when Citrix ADC performs an ARP update against its own IP address. GARP or gratuitous ARP updates are sent out by the new primary for all the floating IPs configured on the Citrix ADC HA pair. The GARP update are staggered or throttled to 40 packets every 200 milliseconds, and we send 2 GARP updates per IP address. The primary node responds to Address Resolution Protocol, ARP, request with its own MAC address. The ARP table of an external device, such as an upstream router, is updated with the floating IP addresses and the MAC addresses of the new primary node, and all of this is done via the gratuitous ARP update after a failover event. To configure Citrix ADC nodes in a high availability pair, you need the following. You need the same type of appliances and the same RPC node password. Requisite ports must be open, such as the heartbeat packet port, as we mentioned a moment ago, of UDP port 3003. You don't need the same NSRoot password because if they are different, they will propagate from the primary to the secondary. If the build is not the same, you can configure HA, but synchronization will not occur until they match. One has been updated to the other. The Citrix ADC needs to be the same type of appliance, such as all MPX, all of them VPX or CDX, and the same version build of the software, as we mentioned a moment ago. The next topic that we're going to be talking about in this webinar is global server load balancing. What is it? Well, to put it very simply, it's DNS management. If an end user, customer, or employee asks for a resource, we can load balance that request across multiple data centers, even if they are globally placed. Disaster recovery is providing an alternate location for accessing resources in the event of a failure, or a means of shifting traffic easily to simplify maintenance, or could be both of those reasons. Load sharing is distributing traffic between multiple data centers to manage bandwidth costs, to manage the load to the capacity at any given location, and reducing exposure to various issues including outages, natural disruptions, and so on. And then another reason for doing this, setting up GSLB, is performance, to position users closer to content which enhances the user's experience. And finally, there are legal considerations. We want to present users with different versions of resources based on geopolitical constraints and locations. The GSLB architecture, global server load balancing, is a DNS-based technology that provides disaster recovery and ensures continuous availability of applications by protecting against points of failure in a wide area network. GSLB can balance the load across data centers by directing client requests to the closest or best performing data center or to surviving data centers in case of an outage. The following examples demonstrate the process of a GSLB conversation. The client enters, say, www whatever site into a browser. The system of the client sends a DNS lookup query for that website to the name server that is configured. The name server returns the IP address for a known name server who is authoritative for that website, as delivered by the root server. The return address will be one of those registered for that site. The top-level servers, or root servers, circle through the list round-robin style and will return the next IP address in line. The client queries the Citrix ADC system in the GSLB configuration at the IP address returned by the top-level root server. The Citrix ADC system is based on its configuration, load balancing methods, and its monitoring, returns the IP address the client needs and has presented in their query for the service it's looking for, such as HTTP or HTTPS. Now, design considerations. Application proximity. Some applications do not support multi-site deployment due to complexities or synchronization, possibly licensing or geopolitical reasons. Which networks should carry the load? The location of application data determines which network should carry that traffic. Persistency. Many applications require persistence upon continuity of user interaction. These are all design considerations when setting up GSLB. The last one is user data. Considerations of user data, like roaming profiles, can be replicated across sites so that the user request is redirected to any site where their data happens to be. In an active-active data center setup, both the NetScaler appliances and services, the network traffic for the domains for which the appliance is authoritative, are active to ensure that the data is consistently available at each distributed data center. Active-active data center setup. If Site 1 receives the client request, the GSLB virtual server in Site 1 selects a load balancing or content switching virtual server and sends the virtual server's IP address to the DNS server, which then sends it to the client. The client then requests or resends the request to the new virtual server at the new IP address. As both sites are active, the GSLB evaluates the service at both sites when making a selection as determined by the configured method of load balancing. In an active-passive data center setup, then the only time traffic is sent to the secondary site is if the first site becomes unavailable. So if site 1 goes down, site 2 becomes operational. When the client sends a DNS request, that request can land at any of the sites. However, services are selected only from the active site as long as it's up. Services from the passive site are selected only if the active site is marked as down. To enable a smooth failover in the event of a disaster, an authoritative DNS server query are addressed only by the active sites. Passive sites become operational only when the active site goes down. Another consideration is proximity. Now, proximity has two settings. You can set up a static proximity or a dynamic proximity. Static proximity determines the site to direct the client to based on proximity to geographic locations in a static location database. We use commands in configuration and population and the location database to set up static proximity. Dynamic proximity, we measure dynamic RTT or return time. The NetScaler system probes the client's local DNS server and gathers the RTT metric information. The GSLB monitors the real-time status of the network and dynamically directs the client request to the data center with the lowest RTT value. Static proximity, client sends a request to resolve citrixtraining.com, for example. Information related to the domain is stored at 3 data centers, the US, European, and a offsite. Site A, Site B, and Site C. If the local cache and the local DNS does not have the IP address for the requested domain, then it sends the information to a ADC appliance that is configured as an authoritative DNS for the domain. After receiving the request from the client local DNS, the NetScaler uses a static database to determine the IP address and location information for the client browser. And then the client browser displays the web page or the resource. To add a third-party static database file on the NetScaler appliance, complete the following procedure. Get the database file from the third-party vendor. Third-party vendors such as maxmind.com or ip2location.com. Copy this location database file to the appliance using a WinSCP utility. Run the following command to ensure that the location database is located. Show location parameter. This command displays the parameters such as number of static entries and error messages. If the database is not loaded correctly, you'll get that error message. A maximum of 3,000,000-1 entries can be loaded. Run the following command to view the location of the GSLB site. Show GSLB service. A typical use of static proximity is when end users travel widely, such as a user normally in the US and that user's data and profile is in a US data center, but they're traveling in Europe. The GSLB will resolve their request back to the US where their data is residing. Monitoring sites and services. Metrics, we use the MEP protocol or metric exchange protocol. It's used to synchronize the data used in GSLB calculations across multiple sites. 3 types of data are exchanged in a MEP communication. MEP communication is accomplished between each GSLB site on TCP port 3011 or 3009 for secure communications. And therefore, these ports must be open on all firewalls. It is necessary to have MEP enabled on all GSLB sites. The three types of data exchanged is the site metrics exchange, the network metric exchange, and the persistency exchange. Now, the site metrics exchange is a polling exchange model. Every second, Site A queries Site B for the status of the GSLB service, and Site B responds with the status and other load balancing details. Now, the network metric exchange, the LDNS RTT information exchange, which is used in the dynamic proximity load balancing, a push exchange model. Every 5 seconds, each site pushes its data to the other participating sites. That's the network metric exchange. Persistency exchange for source IP. Persistency exchange, also a push exchange model. Every 5 seconds, each site pushes its data to other participating sites. That's GSLB in a nutshell. Now, on to our final webinar topic. The fifth and final topic of our webinar today is Citrix ADM for analytics. Citrix Analytics collects data across all Citrix portfolio of products and third-party products. Citrix Analytics generates actionable insights, enabling administrators to proactively handle user and application security threats, improved application performance, and it supports continuous operations. Citrix Analytics is available as a cloud service delivered through the Citrix Cloud. Citrix Analytics gathers data from the products and uses built-in machine learning to determine or detect anomalous user behavior, monitor and troubleshoot user sessions, and view operational metrics for users across an organization using Citrix products. I wish I had hours or even days to share with you the exciting world of Citrix Analytics. In the time remaining on this webinar, let's concentrate on Citrix Analytics as a service. What is it? What is security analytics? Well, security analytics is an analytics service that allows you to monitor and identify inconsistent or suspicious activities on your network. It provides actionable insights such as user behavior, usage based on indicators identified across users, endpoints, network traffic, file access. Recent studies indicate that online threats have evolved to attack company resources from inside. Protecting internal users from an imminent attack is as important as protecting a company's network resources. Corporations must be able to shield its network resources and applications from any unauthorized or suspicious access. Users within the company share network resources such as the internet. As a security officer, your objective must be to monitor and identify events that are potentially suspicious. The events can also be inconsistent with the requirements or procedures within the company. So when a user connects their mobile devices and laptops, monitoring and flagging these events becomes even more important so the potential threats can be predicted and downtime avoided. So let's talk for a moment about security analytics. Citrix Analytics is an analytics service that allows you to monitor and identify inconsistent or suspicious activities on your network and provides actionable insights. You produce a risk score. Now, a risk score is a value that indicates the aggregate level of the risk a user poses to the network over a predetermined period of time. This value is dynamic and is based on user behavior analytics. Those analytics study and determine patterns of user behavior. These algorithms are applied to analyze anomalies that indicate potential threats for a defined monitoring period. Risk score is an aggregate of the risk indicators that are triggered for a user. We determine through the analytics risky users. A risky user is determined by their behavior, such as the links they visit. A risky user associated with a risk score can either be managed with one of the following types. A high-risk user represents immediate threats to the organization. A medium-risk user are users that could have multiple serious violations on their account and must be monitored closely. Or low-risk users who may have some violations detected on their account but don't pose an immediate risk. We can also produce a watch list, a list of users that you want to monitor for potential threats. For example, you can monitor users who aren't full-time employees within your organization by adding those users to the watch list and monitoring them separately. Or you can monitor high-risk users using a watch list. Policies. You can create policies with Citrix Analytics to help you perform actions on user accounts when unusual or suspicious activities occur. Policies let you automate the process of applying actions, such as disabling a user, adding users to a watch list, or so on. Actions. Actions help you respond to suspicious events and prevent future anomalous events from occurring. You can take actions on user accounts that display unusual or suspicious behavior. For example, you have an employee by the name of Kieran. Kieran is an employee. He never works on Saturdays, but last Saturday he or someone using his credentials tried to log in. The analytics system noticed that the behavior was not normal for Kieran, and it triggered, based on the administrator's configuration, it triggered a deny logon. It also sent a message to Kieran's administrator, and it logged the action or any actions that were taken and the event that triggered the action. So those are the things that we can do about the security analytics. Let's take a look at some of the dashboards that you can view while using the analytics. There are 3 security dashboards where you can view details about user behavior. The user dashboard provides visibility into user behavior patterns across an organization. The user access dashboard summarizes the number of risky domain accesses and the volume of data uploaded and downloaded by the user in your network. App Access Dashboard summarizes the details of the domains, URLs, and applications accessed by the users in your network. And you can see we've got the categorization of the risky users, high-risk users, medium-risk users, and what users are currently in the watch list. There are 3 security dashboards that you can view details about user behavior. Under the user dashboard, it provides visibility into user behavior patterns across organizations. From here, we can drill down into the devices. The number of devices used by the user to access data resources, how many were simultaneously being used. Citrix Analytics collects this data from Citrix Endpoint Management and Citrix Virtual Apps and Desktops. Click a user name, then navigate to User Info to view the name and number of devices used by this user. The Trend View link at the top right-hand corner provides a graphical representation about the user's device history for a specific period of time. Locations, the places from which the user might have logged on to the data sources. Citrix Analytics collects the data from Citrix Content Collaboration and Citrix Gateway servers. Click a user name, then navigate to the User Info to view the name and number of locations from where the user has accessed the data. The Map View link at the top right corner provides the user's logon location history, again for a specific period of time. How about data usage? Volume of data consumed by the user might include data uploaded or downloaded, files uploaded or downloaded, and the file shares or deletions. Citrix Analytics collects this data from Citrix Content Collaboration. Click a user name, then navigate to User Info to view the details of the data usage for that user. The Trend View link provides a graphical representation, again, on a historical point of view for a specific time period. Apps used, the number of applications accessed by the user during this time period. Citrix Analytics collects this data from Citrix Virtual Apps and Desktops. Click a user name, then navigate to the User Info to view the name and number of applications used by the user. The Trend View, again, provides a representation of the user's application history for any specific period of time. The second dashboard is the User Access Dashboard. It summarizes the number of risky domains accessed and the volume of data uploaded and downloaded by the users in the network. And so you can see that you have the user, what access, and where they were going. You can click more details to view a complete list of users who have accessed the risky domain. The top risky user by download volume section. This dashboard provides the details of the top users who have uploaded or downloaded large volumes of data from domains that are categorized as malicious or dangerous by access control. It provides the user account name, the volume of data uploaded or downloaded by the user from those risky domains. The third dashboard is the App Access Dashboard, and it summarizes the details of the domains, URLs, and apps accessed by the user in your network. For the selected time frame, in the App Access Summary section, the dashboard provides overview for the number of malicious domains, dangerous domains, unknown domains, clean domains accessed by users in your network. It also provides the volume of data uploaded or downloaded from any of or all of those external domains. Then you can create this report, Top Risky Domains, and you can take a look at the different domain, the category, program downloads, gambling, lottery, infected sites, gaming, whatever, whether the action is to block or allow, and how many users are touching those domains. So the Top Risky Domains by Access section provides details about the malicious or dangerous domains that were more accessed by the users in your network. It provides details such as the URL of the risky domain, the category to which the domain has been categorized by access control, the action taken by access control to mitigate the risk, and the number of users who have accessed that URL, with the increase in trend of the number of users accessing this risky domain for the selected time frame. The Top Risky Categories by Access section provides details of the category of the domain that were accessed, the highest number of times by the users in your network. It provides details such as the category to which the domain has been categorized, the number of users who have accessed the URL with the increase in trend, the number of transactions by user on the risky domain with the increase in trend of the number of transactions by users on the risky domain for the selected time frame. And again, we get a list of how many transactions were blocked by access control. Citrix Analytics gathers data and provides the following insights. Security Analytics collects and provides visibility into user and entity behavior. You can track all aspects of user behavior by leveraging advanced machine learning You can distinguish between normal employee behavior from that of malicious attacks, thus enabling you to proactively identify and manage internal and external threats. Performance analytics. Performance analytics provides visibility into user session details across an organization. By using the data, organizations can proactively monitor and troubleshoot issues that arise during a user's logon session. The user session data also displays logon duration and network latency data as well. And the last area of analytics is operations analytics. The operation analytics collates and presents information on the activities of users, such as websites visited and the bandwidth spent. It also reports bandwidth usage and detects threats such as malware and phishing sites. You can use these key metrics to monitor your network and to take corrective actions. Well, in this webinar, the key takeaways that I hope you were able to take away from the webinar is how important is business continuity. Citrix ADC for mission critical applications and services is a good solution. How do we protect the ADC? We protect it with high availability. Global server load balancing is a must if you have multiple processing centers or multiple data centers where your processing load is distributed. And Citrix ADM for analytics, very important to the business. And this brings us to the conclusion of our webinar today. I and everyone at Citrix Education want to thank you for attending. And now, Leslie, what is this slide all about?
Thanks, Jeff. So we have some education announcements to make in regards to certifications and some promotions. Right now we have two recertification promotions going on through the end of the year. So if you sit the 315 class on or before December 31st, you can recertify your expired CCPV certification. And then if you have an expired CCE certification, you can recertify by sitting the CWS 415 course. Now, what this means is there is no need to take and pass an exam. You just simply need to buy the ILT, sit the course on or before December 31st, and then you can recertify. The next announcement is the buy one, get one half off now through September 30th, so the end of this month. If you purchase one instructor-led training course at full price, you get the second half off. And you can either sit both of these courses yourself, or you can share them with a family member, friend, or coworker. And if you want to visit the bit.ly links that are up on the screen, that'll take you to a blog where you can get in touch with a Citrix education rep, and they will help you with your purchases. And that's it. Very good.
Thank you all for attending our webinar today, the Lead, Learn, Educate, Accelerate, and Discover. Again, my name is Jeff Apsley. Thank you for being part of our webinar today. Have a great day.